grade minor again. When you label the wavelength, if you start at the beginning of a compression, you go to the beginning of the compression. Now, you don't have to start at the beginning of a compression. All right? You can pick a different spot.
You can start in the middle.
Yeah, you can start in the middle of the compression and go to the middle of the compression.
You start at the beginning of
You can start at the beginning of the rarefaction.
You can start wherever you
Okay? And go to the beginning of the rarefaction. Now, their argument is, if I start at the beginning of the rarefaction, I go to the beginning of the rarefaction. Now,
You mean if you start
am I at the beginning of a rarefaction here and at the beginning of the rarefaction here? That's the end. That's the same rarefaction. Okay? And I can't make some people see that. If I'm here at the beginning of the rarefaction, I have to have a what in between. I got to have another compression. So I have a whole rarefaction and a compression to get to the beginning of the rarefaction. Because in order to have a wavelength, you have to have how many parts? 2. A compression and a what? And a rarefaction. That makes up the complete wave. Just like in a transverse wave, what makes up the complete wave? What makes up the complete wave in a transverse wave? A crest and a trough. Okay? So, a complete wave here for most of you is a crest to a crest, or a trough to a trough. That would be a wavelength. All right? So, most people tend to go from the beginning of a compression to the beginning of a compression, which is fine. Now, when you go to calculate the frequency in the period, it works the same way. What do you look at to figure out how many waves there are when you do this in this top wave? Again, what makes up a wave in a longitudinal wave? A compression and a what? Rarefaction. So, how many compressions are in this wave? Can you tell me?
2.
There's one here,
3.
and there's one here,
I think.
and then what happens here? You stop because you got the time. So there's how many compressions before you hit 1 second?
2.
There's 2 compressions, and you see 1 second. So the frequency equals 2 waves over 1 second. So it's 2 hertz. Now, how would I find the period for that? I heard Alizé and she's right. What about the rest of y'all? All right, it's 1 over the frequency. Now, a couple people said yesterday, Ms. Wall, where do you get that 1 from? Where's that 1 come from?
The first wave.
It's the formula. Okay, that is the formula. I didn't get it from anywhere. That's the formula. So period equals 1 over 2, which is 0.5 seconds. Now, for the second wave, all right, for my second wave, how many waves do I have? How many waves are here?
4.
So 4 over, what's my time?
3.
So what's 4 divided by 3? 1.3? 1.3 hertz. Better be right since y'all didn't tell me I'm wrong. All right, how do I find the period? All right, period equals 1 over 1.3. What's 1 divided by 1.3? Point what? 0.3 repeating seconds. Questions about how to do that? Some of you got every one of those questions wrong on the back side of the quiz. All right, let me send Logan out, Raul out, Damien out. Sacramento, put your phone up. I think that's it.
No, this is a quiz.
It's a quiz. Test is Monday. And the test on Monday has 47 or 48 questions. Everything counts 2 points, so it's pretty
Is that
close to
multiple
50.
choice, or it's like how many-
40 of it is multiple choice, and the rest of it is free response. I just ran it off a little bit ago.
So everything is, multiple choice except the back page.
Everything's multiple choice except the back page. Just like usual. Somebody close the door. There's no point in me sending them out. Might as well be standing in here with us. All right, what's the low point on a wave called? Trough. A wave in which the motion is parallel is called what? You can say compression or longitudinal. Either one was fine. All right, the distance between two consecutive crests is called a wavelength. The unit used to measure the frequency is called hertz. 5 was an unmitigated disaster. Okay, it was just a mess. Wave velocity equals wavelength, what frequency? Times multiplied by, I took either answer. Okay, times or multiplied by.
I got confused, but hold on.
Yeah, it was a mess. An area in a compression wave in which the particles are spread out. Rarefaction. All right, an example of a medium is a,
Solid.
I took solid, I took liquid, I took gas. I had people, I had one person in a hot tub, I took it. Okay, I had floor, I had water, I had all kinds of things. All right, if you took and wrote any kind of example that involved something legitimate, for the most part, I took it. All right, find the wave velocity. This one you had to solve. And again, all right, we'll compliment Alexis over here because she did her math. And Alexis has struggled with the math all semester long. She wrote the formula down and she plugged in her numbers and she did it right. Okay? Velocity equals F lambda. It says find velocity. Frequency is what? Frequency is 12. Times wavelength is 4. So all you have to do is what? 12 times 4. Meters over seconds. Now, she got, I don't know if she lost a point for unit. Some people did, some people didn't. Now, what is wavelength? Wavelength is which of those letters? It's the lambda or the stick man. So we're looking for stick man this time. So we got V and F. All right, the speed of the wave is 12. So speed is 12. That goes there. Frequency is 6. How do I solve? Divide by. Okay, so lambda equals 2, and we need a meter because it's a length. Now, this bottom, I was a little disappointed in this bottom. I really thought these were gimme questions. Everybody was going to do great. I was stunned, speechless when I graded this. Okay, this should have been an F. Some of y'all didn't even write down the F, so you couldn't have possibly got that answer right on that question. All right, which letter represents amplitude? A is not an answer to anything. Okay, it goes from the top of the wave to the bottom of the wave. It's not anything. All right, amplitude is from here to here, or it could be here to here, but that's it. So amplitude is C. Which letter represents a crest? E. All right, a trough of the wave is F. If you didn't write F down, you were toast on that one. And then, which letter is a wavelength? D. That's why when I handed back all those papers, or when we were drawing the waves and you brought me your wavelength, I used whiteout to get rid of your wavelengths if you drew them down here or you drew them like here, and I told you they were wrong, okay? They can't be drawn there. Right? It can't be there. It can't be there. It's got to go all the way across, or it's got to be up here. It's got to go all the way across. Now, calculate frequency. Is frequency ever going to be a letter? No, it's a number. You always have to say the number of waves over the what? Over time. So how many waves are there? Over what time? 3/1 is 3 hertz. Okay? On the back side. Okay? Which one of those waves has the least energy? It's C. Okay? What can you tell me is the reason?
Because it's the one that has the lowest amplitude.
Has the lowest amplitude. Okay? Frequency, count the number of waves. There are how many?
4/2.
4/2 means it's 2 hertz. To calculate period, it is 1/2, which is 0.5 seconds. Number 18, same thing. How many waves are there?
2 waves.
Over 2 seconds is 1 hertz. Period is 1/1, which gives you 1 second. Now, you had to measure these. Between here and here is one place, but it's not the only place. You should get 1 centimeter. Here, pick a spot. If you do the front of the compression to the front of the compression, you get somewhere around 3.4 centimeters. Now, I gave you quite a bit of leeway there. You can be off a couple point somethings. I think I even took as low as like 3.1 centimeters. Okay? Now, if you put 2, I just marked it wrong. Questions on how to do that? Okay. Now, you hand out the papers. Somebody come get my key and unlock the computer cabinet. I'll let them back in before I forget them and leave them out there. Everybody come get the key and unlock my cabinet. Okay, somebody else go let them in out of the hallway. And they're likely to be there for a while. Huh? During what? Yeah. I'm not organized. And Jack, when you finish, just put the extras on my desk. Tell me more about something. Already.
No, it's the original as well.
45.
I'll take
You what?
That's the original.
Yeah, if you're gonna stay for lunch, it's fine. All right. You're gonna need your laptop. If you look on Google Classroom, there are either 3 or 4 websites that say Wave Interactions. Okay, it will help you do this. It is a grade. Some of us got zeros the last time. Please don't let me give you a 0 again. Yes, I will. Alan needs 6. Six and 18.
That's how
I think this-
What job would you get?
A zero.
A zero?
It's a Google Classroom, it says wave interactions. There's a few of them, either 3 or 4.
Zero.
No, it will not be at the bottom, it will be somewhere in the middle.
That's not much. No, I'm not trying to get. I'm not trying to get a 10.
Yep, wave interactions.
Thank you. What's your name?
All this time was there.
The offside.
If you're not somewhere, vote.
You can do what today?
Huh? Yes. Read all of it. Okay. The idea is to open it up and do your own. Huh?
Can't spell or read today. I don't know what's going on.
No. I think you're right. Will you say examples, these are like this or just like water sound, stuff like that?
Like, for example, reflection, an example of a reflection would be an echo.
And refreshing, I put a straw in a glass of water.
Sure. Every time y'all get a drink at a restaurant, y'all see refraction. Yep. I would believe it. I would put it down for something different, but I'm not gonna say it's wrong.
Mm-hmm. All right, I like that one. I like that one. That was my favorite. Remember, for examples, you want at least 3, not 1. You could draw either of those two up there, something like it. For example, here's an example of their appearance there. Picture can go there. Another picture of the fence. I mean, reflection. Yeah, that's why it's all. Construction would be, you could do, the pictures, that's construction, all those are constructed. So you move it, so it doesn't work. The one I got is one like this, one like that. This is not a drawing. Cause I pasted one that was a lot better than me hand drawing it. Good job. You done? Or you just get up? Yes. I do. Finish special needs, I'll be up there recording. You can charge me. You gotta take them back, so you go.
Yeah. Can I get some water?
What about him?
The mail's done? I can't break it. I just give you a door knob.
Give me a one. Sure. Stop the tuning forks. I'm listening to them all too soon. Okay, what's that? Okay.
This is out of order. Constructive language. She did not let me have it. They made me do it. And I didn't have the ball. So I put it in the bag. Stop it. It's embarrassing. It smells good. It smells good. Take it out further away. I have a ball.
Shoot. I'm arguing about it. If you're done, make sure you bring me your paper. I'd like to see everybody's in the next couple minutes.
Well, what if we drop the picture for interference? So, just one of the things
Hey, what?
for the picture for interference.
Just one of the pictures. Doesn't matter to me which one. Did you show me yours? I did?
Yeah.
Well, I haven't seen Nathaniel, Janaya, Sierra, Raul.
Logan, or Roy. You can see Roy's, Alize's, Raul's, Shania's, and Nathaniel's.
You have some. Phoebe can tell me what that looks like. Parties. Phoebe. Just taste it. It's done. Taste it. Just taste it. Rainbow I thought I was cool too. Have you seen all these little girls come on music? Yeah, that's weird. And they in North Carolina too. They're going watching their kids. Because the mama don't care. And then when they put their kids, they kidnap. I think it's because they letting them like walk to school and stuff by themselves. They can't do that. The little girl. I seen that. I didn't know that was just like, I didn't know it was now. You could have seen it on the page.
All right, I need to see Jania's, Raul's, and Roy's paper. Like now, even if you're not done. I need to see what it is you have done. Like pronto. Janai, what do you say?
Just like, because there is no percent.
I see it.
A nigga can.
It's on good
But a
percent.
nigga can
What?
like,
I'm guessing around like
I'm sorry, nigga, but I thought it was your ear. I'm sorry.
All right, let's run through a couple things to hopefully make life easier for you when you do the lab. Okay? Because this is one I usually get a lot of questions about when I let you loose with the equipment. I hope. It is not one that a lot of students like in the sense that there's not a lot you have to write down. Okay? It's one that has a lot of places to write answers, but there's not a lot you have to write down. Okay? Because there's essentially 2 columns. Matter of fact, I'll let you have the lab sheet now. So you see what I'm talking about. I'll let Alexis hand it out. All right, Alexis, give everybody one so I can see what I'm talking about. Now, you have all this written down. We're just going to. Really?
Really?
Somebody hand out the lab sheet. I don't care who.
You know I'm lazy. You know you would look you at me. You know for you to somebody else.
That is a gross understatement.
Look, it's good.
Now you put the phone up. All right. When we get up to get the lab stuff, I'll let you put your laptops up. First of all, every year I have the same problem, so let me make sure everybody's clear. When you read the instructions and you're making your observations, you turn the paper over. There's a place for observations on the back side, okay? So don't write all the observations on the front and then be like, dang, she wants me to rewrite that on the back. No, I don't want you to rewrite it. I wanted you to write it the first time where? On the back, okay? So your observations, what you see, go on the back. Now, the 2 columns that have answers are the middle column and the 3rd column. Now, this is where people get stuck and they're like, I don't know the answer. So, your first graphic organizer you did that I told you we were using today is the one that has mechanical waves, electromagnetic waves, and surface waves. So I hope you know where it's at because we're going to use them today. Okay? So, how do you know if something's a mechanical wave? It has to have a what? It has to have a medium. Okay? So, if you're using something that requires a medium as a mechanical wave, what fits as a medium today? So, such as what state of matter? Solid, liquid, and gas. So if you have a solid, like you're using water or liquid or a solid like a tuning fork or something, then it might be a mechanical wave. Now, what would fit as an electromagnetic wave? Such as what? What's the biggest electromagnetic wave we use? You're not using any X-rays today. How am I going to put X-rays up here? That's right. I've given you lots of examples of visible light. All right, that's going to fall under electromagnetic waves. Now, to be a surface wave, what did we say you had to look for to be a surface wave? It had to have 2 different mediums. You might even see what else going on. Circular motion. Okay? Now, those are your. Sitting in your desk. You're not paying any attention to what I circled or highlighted. Did you look at your graphic organizer that we did 2 days ago? Did you get it out? I saw a couple people look it up and pulled it out. Did you make sure you looked at those things? Don't come up to me and ask me because I'm going to look at you and go, oh no, I didn't get that. It's not my problem. You didn't ask for it when you got back either. Now, today, you took notes on the 4 wave interactions. So, if you wrote down reflection, I don't need that page, it just tells me what they are. All right, what's the key to being reflection? Bouncing what? You're looking for a wave that bounces back. If it doesn't bounce back, it's not reflection. All right, it has to go out, it has to hit something, and has to bounce and come back. That's the key to reflection. Goes out, comes back. Goes out, comes back. So I wrote down some examples of an echo, hits the side of a pool and comes back. You ever jump to a swimming pool, watch the wave go out and come back?
Yeah.
All right. How many of y'all look in a mirror?
Me.
I do it every day when I get ready to come to school. I don't want to look so bad. All right. That's reflection. Now, refraction. This is the bending of a wave. Now, there's 2 bendings of a wave, but refraction is the bending of a wave because you have a change in a medium. So, the example I used was like a spoon sitting in water or a straw sitting in water. I think it was Brianna who said, can I put a straw in water? I said, yeah. Anybody who goes to a restaurant sees it every time. You have air above the glass, water below the straw. You have air, water, it's 2 different mediums. If you get down and look at it, the straw is going to look bent where the mediums change. It's not going to look straight at that point.
My example.
Okay? Now, other things that I put here was, why does the speed look different? Because you have 2 different mediums. Do the waves travel the same speed in the 2 different mediums? No. All right? Diffraction. All right? There's 2 different definitions you could use here. These waves bend also. Any of y'all ever sat in a classroom and heard another teacher talking? You can right now. All right? That's the bending of a wave around 2 edges. Okay? So when Miss Bowers' class can hear me talking, or I can hear Miss Bowers talking, her voice bends around the wall. I can hear Miss Rector singing because their voices carry around the edges of the wall. That's diffraction. All right? Now, I can't draw very well. But if you have a wave that passes through and creates new waves, when little waves go up there, you get diffraction. Now, interference, which y'all drew. Lord, in these blinds today. All right, 2 or more waves. All right, occupy the same space, and they combine to form a new wave. Now, see what I wrote in red? This is the part people don't get. Once the waves pass through each other, they go back to their original shapes. So, most of you who drew constructive interference at the bottom, you drew them getting bigger, right? Do they stay permanently bigger? No. They get bigger for a minute. After the wave gets bigger, they go back to their original size after that wave goes through it. Destructive interference. Okay? So the waves approach. One goes up, one goes down, waves get smaller, and then they go back to their original size. They don't stay small or big forever, okay? Once those waves pass and the interference goes away, then they go back to their original size. Yes?
Like 2 waves in water.
Yes, and then they go back out to their original size after they get done crashing. Yes. Correct. Questions? All right. Now, on the lab sheet, so here you can see this one looks better. So you got a big wave, a little wave. They meet up and cancel each other out. And then what happens after they go through? They go back to their regular size. Now, on the lab sheet, you have 2 columns. The first column asks you in that middle section to tell me if it's electromagnetic, mechanical, or surface. The last column asks you to tell me if it's refraction, reflection, diffraction, or interference. Okay, so there's 2 parts. Now, in the tins at the back, you have all of your equipment. Please don't shine the flashlights in people's eyes. Whoever gets the tin for your group is going to need to put their hands under it. It's heavy. The tin is not very strong. Okay, there's a mirror in it. There's a eyeglass piece. There's very breakable. There's a beaker in there. It's all breakable. Please do not drop it. You're in groups of 3. There is one group of 4. I chose the groups. Don't really care if you don't like the groups. Okay? I have one calculator that's out and about that needs to be put up because you're not using calculators. Okay? And I'll put this up here so you can see who your group's mates are.
No, I can't.
Now, this is 1 group per counter, okay? There's 6 counters, so 1 group per counter. 1, 2, 3, 4, 5, 6. I don't care which group is at which counter, okay? Those are the people I put with. Who's who?
What, Bob? Oh. And we said we're Thank you.
Now, y'all both can't do that. I said 1 group per table. Y'all are not the same group.
Oh.
Vincent's phone, Vincent.